Welcome to this training on the metal alloy special condition developed in alignment with the HPD collaborative framework. Today, we will discuss how metal alloys are handled as a special condition within product inventory reporting. This is essential for accurate material disclosure and health-based hazard screening. Let's get started. Here's what we'll be covering today. 1. We'll begin with a clear definition of what a metal alloy is. 2. Then we'll explore why metal alloys require special condition handling. 3. Next, we'll define the scope of this special condition, what's included and what's not. 4. And finally, we'll walk through how to report metal alloys correctly using the HPD Builder system. Understanding these points is crucial for proper hazard assessment, regulatory compliance, and transparent reporting. A metal alloy is a material formed by combining two or more metals or metals with other elements to enhance material properties like strength, corrosion resistance, or malleability. For example, stainless steel is made from iron combined with chromium and sometimes nickel. We also refer to individual alloying elements, which are the building blocks of an alloy. These may include zinc, copper, manganese, lead, and others. Each of these components can carry its own health and safety implications, which is why proper inventory and hazard reporting is so important. Now let's discuss why metal alloys fall under a special condition category. First, alloys differ significantly from their base elements. For instance, combining copper with zinc to make brass alters the toxicity profile, so simply listing raw elements doesn't capture real-world hazards. Second, alloy hazards are complex. Factors like solubility and microstructure influence how toxic or reactive an alloy might be. Third, traditional chemical inventories based on CAS registry numbers may not fully describe an alloy. Industry systems like UNS or CN provide more accurate data, so for compliance and worker safety, we need precise reporting using specialized tools. This special condition applies only to bare, uncoated, untreated metal alloys. If a product has a surface coating or treatment such as paint, plating, or anodizing, those are reported separately in the HPD as distinct materials. This condition is limited to metal alloys with a verified HPD, typically created by the relevant trade association and available in the HPD repository. Now, the special condition supports two methods. Use a trade association HPD if one exists for the alloy, or manually inventory the alloy's components. This flexibility ensures full compliance while capturing all untreated metal content accurately. This new feature within the HPD Builder streamlines how we disclose metal alloys such as copper and aluminum. Key benefits include simplified disclosure, especially for frequently used alloys, support for trade association HPDs or manual entry of alloy components, automated hazard screening using the Pharos tool, ensuring alignment with health-based benchmarks. It's designed to reduce false red flags like BM1 or LT1 scores that might occur with improperly reported alloy constituents. And most importantly, it's now integrated directly into the HPD Builder interface. Let's begin our walkthrough of how to report a metal alloy using the special condition feature. Step 1. In the HPD Builder, go to the Substances section. Select Materials, then click Add Material. Choose Add Nested Inventory. This tells the system you'll be entering a grouped set of substances like an alloy. Enter a common name, for example, copper alloy. This step begins your content inventory process for metal alloys. We'll continue these steps in the next slides. Step 2 in the reporting process is to select metal alloy from the list of special conditions. Once you do that, you'll be prompted to check for an existing trade association HPD. This step activates automated screening, saving you time by autofilling elemental data and reducing the potential for manual entry errors. This ensures consistency across disclosures and aligns with accurate reporting standards as defined in the HPD Open Standard. Step 3. If a published trade association HPD exists for the metal alloy you're using, select Yes. Even if you're unsure, selecting Yes allows you to confirm supported UNS alloys, for example, C83600. a common copper alloy. This triggers auto-population of alloying elements and applies automated hazard screening using the Pharos database. Green screen scores and other relevant hazard data are populated automatically, streamlining compliance and increasing reporting accuracy. If no trade association HPD exists, you'll proceed with Step 4, manual entry. Here's an example. For aluminum 9664 alloy with UNS number A96061, you'll need to enter alloying elements manually, e.g., aluminum 97%, copper 0.3%, tin 1%. Assign roles to each element, typically as alloying element. This approach is flexible and ideal for custom or proprietary alloys that don't yet have a public HPD. Once all data is entered, you'll complete Step 5 by saving and previewing your HPD. When saved, the following occurs. The Pharos system screens all elements for hazards. Screening results, such as CAS numbers, green screen scores, and additional listings, like Prop 65 or IAR classifications, are displayed. This ensures that your hazard information is complete, accurate, and transparent, critical for worker safety, environmental reporting, and regulatory compliance. This special condition offers a range of practical benefits. Automated hazard screening that saves time, reduces the risk of manual entry errors, helps lower BM1 and LT1 scores by properly contextualizing alloy hazards, streamlined disclosure using trade association HPDs, full support for manual entry when needed. Let's expand on those benefits. This special condition improves the accuracy of metal alloy reporting by recognizing that alloys behave differently than their individual elements. It reduces the chance of inappropriate BM1 or LT1 scores. It promotes transparency for HPD users by making the alloy's composition and hazard data accessible and easy to understand. And it supports full regulatory compliance by aligning with established HPD reporting standards and best practices. As we wrap up this section, remember, every metal alloy disclosed through this special condition is characterized, identified, and screened, ensuring that every material reported is not only listed, but evaluated for its true health and environmental impact. This step is foundational to producing documentation that supports workplace safety, product transparency, and responsible material selection. When reporting a metal alloy under the special condition, one key requirement is that it must be characterized. That begins with using a precise material name taken from the HPD's product name section. This name should include both the generic alloy type, e.g., aluminum alloy, and the UNS code, e.g., UNS A010. Avoid general labels like aluminum alloy. Instead, write aluminum alloy UNS A2010. Also, be sure to assign the material role, such as structure component, based on how the alloy is used in the product. This supports accurate categorization and downstream hazard evaluation. The second requirement is that the material must be identified properly. This is similar to the characterization step, but focuses on ensuring that the name and role used are consistent with the product HPD. Again, enter both the alloy type and UNS or EN identifier. This provides clarity and traceability. For example, aluminum alloy UNS A010 is preferred over a vague label. Always assign the correct material role to match the functional purpose of the alloy in the final product. This is key for both compliance and accurate hazard screening. The third requirement is that the material must be screened. There are two options for meeting this. Option 1. Use a trade association metal alloy, HPD, which already includes full content inventory and hazard screening. Simply select the HPD from the drop-down. Enter the hazard data source such as Pharos, which provides screening details. Option 2. Manually enter all alloying elements, residuals, and impurities into the system. This path ensures that every known substance is disclosed and screened. Both approaches enable accurate evaluation of potential health and environmental risks associated with the alloy. Now that we've reviewed the reporting requirements, characterized, identified, and screened, let's walk through a live demonstration of the HPD Builder. We'll show you step by step how to apply the special condition for a metal alloy using the actual HPD interface. Step 1 in the builder. From the left-hand navigation, go to Substances, Materials, and Polymers. Then click on the Materials tab. Select Add Material to begin entering your metal alloy data. This is the entry point for creating a special condition record. Step 2 in the Add Material window. Under Special Condition Type, open the drop-down menu. Scroll and select Metal Alloy. This ensures your entry is flagged for automated handling under the special condition rules, including auto-population of notes and screening fields. Step 3, confirm whether a trade association HPD is available. If yes, enter the UNS or EN identifier and select the appropriate record. Also fill in the alloy's name. The system will apply the appropriate hazard notes automatically and populate other required fields for you. Once your alloy and associated elements are entered, you'll receive a confirmation message that your material has been successfully added. In the Materials section, you'll now see your entries listed, such as copper or aluminum alloys, along with their nested status and condition. To ensure accuracy, you can click the Preview drop-down to generate a preview of your HPD, helping you verify content and hazard screening before finalizing. Here, we can see the full walkthrough of how data is entered step by step if a trade association metal alloy HPD is not available. First, select metal alloy from the special condition list. Enter the percentage for each alloying element. Assign each element a material role, such as alloy element. This ensures each component is properly categorized and ready for screening. After your initial entries, continue adding the remaining alloying elements like iron, nickel, or magnesium as needed. Each selection should be paired with the correct role and percentage. This completes the full composition of the alloy and prepares the system to generate green screen scores and hazard notes. Once saved, your metal alloy will appear in the materials list under its respective nested material and condition. Here, you can confirm that it's categorized under metal alloys and ensure all screening has been applied. This view confirms your entry is valid, complete, and ready for use in your final HPD.
In this video, we're going to go through the metal alloy special condition. So first we'll come to substances, materials, and then we'll add a material. So first off, this is a nested inventory, so we're going to be adding the nested inventory, and then we're going to be putting the common name. So we are going to start with copper here, and we are going to select the metal alloy special condition. From there, we have two options. We can see, is there a trade association metal alloy HPD? And if there is, we select yes. And if you don't know, you can just come in here and select yes anyways, because you can see all of the different metal alloys, that trade association metal alloys that we have in the system now. And if not, we'll put no. But for this example, we're going to put yes. We've got this copper alloy. You can see that the UNS number and the alloying elements automatically assign based on what that is. Next question is the metal alloy intended for potable water use? That's important for some exemptions. For here, we're going to put no. Doesn't have any nanomaterials. This is going to be a very small percentage of the total adhesive weight. Okay. The hazard data source that we're going to be doing is going to be ferrous, because that's what this product was screened in. And then this is an alloying element, and none of the above for the recycled content. So we'll save that material. So let's go into the next scenario here. So the next scenario is we're going to be doing the same thing, except this time we are going to do aluminum. So let's do NS A 96061 aluminum. And this is going to be a metal alloy. We do not have a trade association HPD this time, so we have to add in all of this information ourselves now. So UNS number is A96061, and then we're going to be adding in all of the alloying elements. So obviously The most common one here is going to be aluminum. And from there, we have to add in the percentage in the material role of the aluminum. So for this specific one, it's 97%. This is the alloying element. And whatever your disclosure ends up being is the disclosure that you'll be adding in here. We're going to put 100 parts per million. Next thing we're going to need to put in is, there is some copper in this. So put 0.3%. And that is going to be an alloying element. And then from there, we'll do one more. There's more, but there's magnesium at 1%. It's an alloying element. If we do have impurities or residuals, we can also be adding that in here as well. But just for this example, we'll put these three in here. There's more. And no for nanomaterial. Again, the weight is going to be very small here. Again, we're using ferrous. And we've got none here, and we'll save this. So from there, what we can do is we can preview the HPD, and you'll be able to see that this information automatically got screened. So if we scroll all the way down to where we just added this, we have our UNS copper. So this is the one that had the HPD already created that we selected, and you can see for copper here, we've got the cast number, and you can see all of the different, you can see the green screen score here, and you can see the additional listings here. Same with lead, tin, zinc, the entire inventory, content inventory is within here. Here's the second one we added that did not have a trade association HPD. So within here, we had to create again add in our alloying elements, and then from there, what happened is the product or the cast number is automatically screened through ferrous, and we can get our green screen score here, and then all of our additional listings as well. So copper, magnesium, and that is what the metal alloy special condition does. You can now inventory your alloying elements a lot easier than before, and also you don't need to use a trade association metal alloy anymore.
That concludes our training on the metal alloy special condition in the HPD Builder. Remember, proper characterization, identification, and screening of metal alloys ensures not only regulatory compliance, but also supports transparent, accurate material health disclosures. If you have any questions, contact support@hpdc.org for technical help or clarification. Thank you for your time and for your commitment to safer, healthier building products.